It's funny, isn't it? We look up at the moon all the time, but it still feels kind of mysterious, like it's right there. But how much do we really know about it beyond, it's made of cheese? Well, today we're diving deep into all things lunar. We're taking your pick, the top 10 must-know facts about the moon article from, 2024. Get ready for some serious myth-busting and more than a few surprises along the way.
Oh, the moon definitely keeps things interesting. For example, did you know that it's slowly drifting away from Earth?
Wait, seriously, the moon's ditching us. Okay, I did not know that. So what's the story there? Why is the moon on the move?
It all has to do with the delicate dance of gravity between the Earth and the moon. You see, the same forces that cause our ocean tides are actually giving the moon a little boost of energy, nudging it just a bit further out into space each year.
So the moon is stealing our planet's energy. That's cold, moon cold. But seriously, how much further away are we talking about here?
Think of it this way. If the Earth were a basketball, the moon would be about the size of a tennis ball, slowly moving about 1.5 inches further away every year. It's not exactly a dramatic, light speed getaway, but over billions of years, that small change really adds up.
Wow, that really puts things in perspective. And I'm guessing that kind of shift, even if it's super slow, would have some pretty big consequences for Earth, right? What happens when your dance partner decides to increase the distance, so to speak?
Well, over incredibly long periods, we're talking billions of years, this change in distance could affect everything from how long our days are to the stability of the Earth's axis. It's just a good reminder that even things that seem totally constant in space are actually always changing and evolving.
Speaking of seeing things from a different angle, I'm ready to tackle another one of those space myths we hear all the time. I'm talking about the whole dark side of the moon thing.
Ah, yes, the mysterious dark side of the moon. It's a popular idea, but the truth is there isn't really a permanently dark side at all.
So no secret moon bases hidden in the shadows? Bummer. But okay, if there's no actual dark side, why do we only ever get to see one face of the moon?
It's not about light and darkness, but rather perspective. You see, the moon is tidally locked to the Earth. What that means is that the time it takes the moon to rotate once on its axis is the same as the time it takes to orbit the Earth. It's kind of like, imagine a dance partner who always keeps the same side of their body facing you no matter how they move.
A cosmic dance where someone forgot to teach the moon the proper steps.
That's kind of cute, actually.
Yeah.
So while we see this one familiar face, there's a whole other side we're missing out on. What's the deal with this mysterious hidden hemisphere?
It's actually a very different landscape than what we're used to seeing. The far side of the moon is a lot more heavily cratered and has fewer of those dark, smooth plains, what we call Maria, that are so prominent on the near side. It just goes to show that you can have some pretty incredible variety even on a single celestial body.
That makes you wonder what else we might find as we keep exploring. But before we move on, you mentioned something earlier about us seeing just over 50% of the moon's surface. That doesn't seem quite right if it's tidally locked, does it? What's the explanation there? Good catch. You see, even though we primarily see the same side, the moon's orbit isn't a perfect circle and its axis is tilted just a bit. What happens is we get this cool effect called libration. It's basically a subtle rocking and nodding that lets us peek just a little bit beyond the usual edge. Think of it like the moon is giving us a sneak peek.
Libration has a nice ring to it, doesn't it? It's amazing how these tiny details can tell us so much about the moon's movements. Now, speaking of shaking things up a bit, I hear the moon might not be as still and silent as it looks from down here.
You're absolutely right. The moon might look all peaceful from afar, but it's actually more active than you might think.
Oh, so what's shaking up there? Are we talking about like lunar volcanoes or something?
Volcanoes, no, not so much anymore. But it does have its own version of earthquakes, which we call, appropriately enough, moonquakes.
Moonquakes. Now that's just cool. But are they like, the same as earthquakes here on Earth?
They both involve the ground, well, I guess the moon ground moving and shaking. But moonquakes are a different beast. There are actually 4 main types, caused by different things. Some happen because of Earth's gravity, others from meteorite impacts, and then you've got some caused by the moon slowly cooling down and, contracting over time.
Wow, so even after billions of years, the moon is still changing and evolving. That's amazing. Okay, let's break those down a bit. You said some moonquakes are actually caused by Earth's gravity. How does that even work?
It's all about those gravitational forces. Think of it as the Earth constantly tugging on the moon. Now, this pull isn't exactly even all around, and over time, it creates stress along those fault lines and cracks in the moon's surface. And bam, deep moonquake.
Wow, our planet is a bit of a troublemaker, isn't it? Causing quakes all the way out there. You mentioned that meteorite impacts can also set things off. Given how beat up the moon's surface is, I bet those can get pretty intense.
You're telling me no atmosphere to protect it, so the moon takes a direct hit from all that space debris flying around. When one of those meteoroids smacks into the surface, well, the energy has to go somewhere, right? It sends shock waves through the moon's interior, and you get what we call an impact moonquake.
That sounds kind of rough, honestly. Yeah. Okay, what about the other kind you mentioned, the ones from the moon cooling down?
Right, so billions of years ago, the moon was a hot mess, literally, molten rock and all that. But it's been steadily cooling off ever since. As it cools, it contracts, see? Kind of like how, I don't know, a cake pulls away from the sides of the pan when it cools down.
Okay, I can picture that. So this contraction puts stress on the moon's crust.
Exactly. And that stress has got to go somewhere. Eventually, boom, shallow moonquake.
And those are the ones scientists are still trying to fully understand.
It's true. They're the most mysterious type of moonquake. It's pretty cool, actually. We've learned so much about the moon, but it still has plenty of secrets up its sleeve.
That is cool. It's a good reminder that even when we think we know something, there's always more to discover. Kind of like that whole dark side of the moon thing we talked about earlier. Speaking of unexpected lunar features, did you know the moon has a tail?
It's a tail, but not like you'd picture. You won't see it with just your eyes. We're talking about a stream of sodium atoms trailing behind.
Sodium. So the moon's tail is basically salty? I'm kidding. But seriously, how does a giant rock end up with a sodium tail?
Think about the solar wind, that constant stream of particles coming from the sun while it slams into the moon's surface.
Ouch. That can't feel good.
No atmosphere to protect it or anything. Anyway, when those particles hit, they knock loose sodium atoms from the lunar soil. Those atoms then kind of get caught up in the sun's gravity and radiation, and boom, sodium tail.
And this is happening all the time. Wild. It really makes you realize how much is going on in space that we never even think about. But hey, let's shift gears back to the moon itself for a sec. I always assumed it was a pretty perfect sphere, but I heard that's not quite accurate.
You heard right. The moon's got a little bit of a, how do I say it, a paunch. It's what we call an oblate spheroid. Basically, it bulges out a bit at the equator and flattens at the poles.
So more like a cosmic egg than a perfect marble.
Exactly. And it's all thanks to the moon's history. See, early on, it was way closer to Earth and spinning much faster. That spin, combined with Earth's gravity, caused that equatorial bulge.
So even though it's slowed down and moved away, that shape stuck around.
Yep. A permanent reminder of the moon's wilder, more energetic youth. Speaking of seeing the moon differently, here's another one for you. I'm always surprised by how many people think you can only see the moon at night.
Oh, yeah, I've definitely heard that one. It's like it magically disappears during the day. So what's the deal? Is the daytime moon just playing hide and seek?
It's just a matter of, visibility. The moon's always there, reflecting sunlight. It's just that at night, it's way easier to see because you've got that dark sky as a backdrop. But trust me, the moon is up there during the day, too. You just got to look a little harder.
You know what? I'm going to make a point of looking for it. It's like a fun little astronomical challenge. Okay, before we wrap up our lunar adventure, you mentioned something about something called Lunar Standard Time. Now, that sounds intriguing.
Right. Who needs Earth time when you can have moon time?
Exactly.
Yeah.
But seriously, is that a real thing? Do we need to buy special lunar watches now?
Well, it's not quite as simple as changing time zones yet. But as we get serious about, lunar bases and longer missions and maybe even moon colonies someday, we'll need a way to keep track of time up there.
That makes sense. Things could get pretty confusing when a lunar day is like, almost a month long in Earth time?
Tell me about it. So Lunar Standard Time, LST, it's a way to standardize everything, like scheduling communication with Earth, planning experiments, you name it. It'll be crucial for any kind of long-term lunar presence.
It's like we're already prepping for a future where humans are hanging out on the moon like it's no big deal.
Exactly. That's what I love about space exploration, always pushing boundaries, always thinking ahead.
Absolutely. Well, I'd say that's a pretty awesome note to end on. We've covered a lot of ground today, from the moon's great escape and its salty tail to its lumpy shape and even its own time zone. It just goes to show there's always something new to learn about our celestial neighbor.
It's true. The moon might seem quiet and familiar, but as we've seen, it's full of surprises. And that's what makes it so fascinating to study. Who knows what other lunar secrets are still waiting to be uncovered?
That is a great question. Big thanks to you, the listener, for joining us on this deep dive into the wonders of the moon. We'll catch you next time for another cosmic adventure.